Hello friends, in this video we will see how to create zeros or how to find zeros in circuit. So okay, so first, if uh, there is infinite impedance between input and output, okay, if there is infinite impedance between input and output, okay, then it will create zero. For example, RC, this is VI, this is VO. Okay, so I will add here at finite frequency. So here infinite impedance, so this Z1, this is Z2, Z1 equals to 1 by SC, okay. This is infinite at S Z equals to 0, so 0 is at origin, okay. Now second point, if impedance between VO or output and ground equals to 0 at finite frequency, so this frequency is zero frequency. For example, say this is R, this is R2, this is R1, this is C1, this is VI, VO. So impedance between output and input is, say this is Z2, this is Z1. Z2 equals to, these two are in series, 1 by SC1 plus R1. This should be 0. So SZ is minus 1 by R1 C1. So at this frequency we are getting 0. Now third point, if there are two paths, if say there are two paths from input to output, okay, and from this path and from this path, so say this is current I1, this is current I2, and I1 equals to I2, both will cancel each other. Say from here current is coming like this, and from I2 this is coming like this. Both are in equal and opposite phase, so this will cancel and output will be 0. Then at that frequency 0 occurs. For example, say this is R, this is C, this is R1, this is C1, say this is C2, okay, this is VI, this is VO. So this is say I1, this is say I2, this is I1, this is I2. So I1 plus I2 equals to 0, and I1 is VI minus, so V output is 0 because we are saying output should go to 0. So VI minus VO, VI minus 0, output is 0, divided by R1 plus VI minus VO, VO is 0, divided by 1 by SC1 equals to 0. So VI is common, cancel, so 1 by R1 plus SC1 equals to 0, SZ equals to minus 1 by R1 C1. So this is 0 frequency. Let's take two more examples. Another is, this is NMOS, this is VO, this is VI, this is VO, this is VI, C. So this is cap between gate and drain, CGD. This is cap between gate and source, CGS. Okay, now this is common source configuration, this is common drain configuration. So here current will flow like this, here this, and say this is ID, GM, VI, and this is say I current. Here this is current will flow like this, II, this is ID, this is GM, VI. Okay, so now let's consider this is A, this is B. So this at output node should go to 0 if 0 is occurring. Okay, now here if we KCL, we need to apply KCL. So II, so this is going toward node, this is going away from node, so here ID. Okay, and VI minus 0 by 1 by SC minus GM VI equals to 0. So VI SC minus GM VI equals to 0. Okay, VI will common and goes to 0. So SZ equals to GM by C. Okay, GM by C. Okay, now let's consider this case. So here if we apply KCL here, then II and ID both are in same direction, II plus ID going towards VO. Okay, so VI minus 0, 1 divided by SC plus GM VI equals to 0. So VI SC plus GM VI equals to 0. So VI is cancelled. So SZ equals to minus GM by C. Okay, now this is right hand plane 0 and this is left hand plane 0. So now here current direction both are different, in opposite direction. One is toward output node, another one is leaving output node. Here current direction is toward output node. Okay, so this you can assume that whenever current direction is same, left hand pole will be there, and when current directions are different, right hand pole will be there. Now in this case, so this is common source, and in this we will get right hand plane 0, and in common drain configuration we will get left hand plane 0. Okay, so here in this video we have seen how 0 occurs, how to create zeros, these things. And usually we put here one resistor. So okay, let's see this thing. What will happen if we put one resistor here? This is cap, this is R, this is C, and so here VI minus 0 R plus 1 by SC, and minus this current is here, this current is here, this is VI, this is VO, which is equals to 0, GM VI equals to 0. So this will be SRC plus 1 divided by SC equals to GM SC SRC GM plus 1 plus GM. So 1 minus RC GM, okay, equals to GM.